In this video, we're going to look at solving rational equations. We have worked with rational expressions and we have learned to simplify those, but these are actually rational equations, and so we are going to be solving for the variable in the equation. The equations are made up of rational expressions, which are fractions with variables in them. And the way we get started on a problem like this is we are going to look for the least common denominator for all of the rational expressions in the equation. So in this one we have all number denominators, so we're looking for the least common denominator for 4, 10, and 5. That is going to be 20, the lowest number that 4, 10, and 5 all divide into evenly. And we are going to multiply all of the parts of the equation by that common denominator. And what that's going to help us do is it's going to help us clear the fractions out of this equation. This should cancel all of our denominators, and if it doesn't, then we have done something wrong or we have chosen the wrong LCD. So here we see that 4 goes into 20 5 times, and here 10 goes into 20 2 times, and 5 goes into 20 4 times. So we come back through, and here, since the 5 is being multiplied by 2x minus 3, we have to distribute, so that's going to be 10x minus 15. Here we have 2 times 9, that's 18. It's our equal sign, and 4 times x is 4x. And now this just looks like a regular equation that we've been solving for years probably. I'm going to move my x's over to this side, so I'm going to have negative 6x on this side. I'm going to combine my like terms, which is going to give me 3. And then to solve for x, I'm going to divide by negative 6 on both sides. And that's going to give me negative 1/2. So that is my answer for x for this rational equation. If I were to plug negative 1/2 back up in here in the place of x, here and here, and check this, it should be equal on both sides when I work it out. Alright, the next one we're going to look at is x minus 5 over 2 minus 2x plus 1 over 5 equals 1. Alright, I see here that I have a subtraction sign, and I'm always worried about forgetting to distribute that subtraction sign through this numerator, so I'm going to go ahead and do that and change those signs. And then I'm going to look for my least common denominator. Again, I have just number denominators this time, so my least common denominator is going to be 10. I'm going to come through and I'm going to multiply each part of the rational equation by 10. And that's going to clear out my fractions. 2 goes into 10 5 times. 5 goes into 10, 2 times. Here nothing cancels because I didn't have a denominator. My 5 is going to distribute through this binomial, and I'm going to have 5x minus 25. Then the 2 is going to distribute through here. So 2 times negative 2x is negative 4x. 2 times negative 1 is negative 2. And over here I have 1 times 10 is 10. Now I'm going to combine my like terms. That's going to give me x. Negative 25 and negative 2 is negative 27 equals 10. I'm going to add 27 and I get x is equal to 37. Alright, on my next problem, let's see here. I have, I'll do it up here, 5 over 6x plus 7 over x equals 1. Okay, now things are changing right here because on the first two we only had number denominators, and here we have some variables in the denominator. So there are a couple of things we have to think about. The denominator of a fraction or a rational expression can never be 0 because that will make the whole fraction or rational expression undefined. So we're going to have some restricted values here for x, things that x cannot be, things that would make these denominators equal 0. So if we set our denominators equal to 0, that one's already solved, and this one, if we divide by 6 on both sides, would also be 0. Then what this is telling us is that we have a restricted value for x, and x is not going to be able to be equal to 0. So why we need to do that is if we were to solve this equation and get down to the bottom and get 0 for our answer, and that was a restricted value, then this equation would have no solution. But we don't know if that's going to happen yet, but we have to go ahead and see the things that x is not allowed to be. All right, so let's get back to the problem. We're looking for a least common denominator here. We have a 6 and an x, so we need both of those in our common denominator. We're going to go through and we're going to multiply everything by 6x. I want to remind you that I have a video on finding the least common denominator for rational expressions. So if you're not sure how I got that, you can go back and watch that video for some help on finding the least common denominator. Okay, when I go through here, this should cancel out all my denominators. 6x will cancel this whole 6x. X will cancel just the x. Nothing will cancel here. So there's no denominator on the 1. This is just going to be 1 times 6x. So over here I'm going to have 5. And then here I'll have 6 times 7, sorry, is 42. And then here I'll have 6x. I can combine my numbers over here to get 47. And then divide by 6 on both sides, and I get x equals 47/6. So our solution is 47/6. We're good. We didn't come out with an answer that was a restricted value, so this is our answer. All right, my next problem, 1 minus 2 over y equals 3 over y squared. Okay, again, we have variables in the denominator. We can't let y be anything that would make the denominators of any of these fractions equal to 0. And so it looks like y is not going to be able to be 0 because that's what would make the denominators 0 on both of these. All right, so that's our restricted value for y. And now our least common denominator is going to be, since we have y's on both denominators, it's going to be the highest power of y that we see, so it's going to be y squared. So that's what we're going to multiply each term or each rational expression in this equation by. Here it's going to cancel the y squareds. Here it's going to cancel one of those y's out of that y squared, and here nothing will cancel. So I'm going to be left with y squared times 1, which is y squared, minus 2 times y, so minus 2y, equals 3. Now this is a quadratic equation, and to solve a quadratic equation, we can do it several ways. I'm going to try to factor, because that's my preferred way to solve it. You can use the quadratic formula. Either of those ways is going to require us to move this 3 to the other side so that we get it equal to 0. That looks like it's going to factor, so I'm going to go ahead and factor it. It's going to be y minus 3 and y plus 1. And now, according to the zero product property, if we multiply two things together and get the answer 0, then one of those has to equal 0. So I'm going to set both of those equal to 0, and that's going to let me see that y is either going to have to be 3 or y is going to have to be -1. So on this one I have two answers for y, 3 and -1, and they're both solutions because neither one of them was a restricted value. So we have two solutions. Remember, when we have a quadratic equation, we should have two solutions because our highest power of our variable is 2. All right, let's do another one. All right, how about a plus 1 over a equals 1 plus a minus 2 over 2a. Okay, once again, we have variables in the denominator, so we are going to have some restricted values. It looks again like our restricted values for a are that a cannot be 0 because that would make this 0, that would make this 0. So 0 is our only restricted value for a. Our least common denominator needs one of all the different factors that we see in the denominator. I see a 2 and I see an a. So our least common denominator is going to be 2a. That's what I'm going to come through and multiply each rational expression by that 2a, that common denominator. Right here it's going to cancel out the a's, and here it's going to cancel out the 2a's. All right, when we multiply 2 times a plus 1, we have to distribute, so I'm going to have 2a plus 2 equals 2a times 1 is 2a, and here the 2a's canceled, so I have plus a minus 2. So I have 2a plus 2 equals 3a minus 2. I need to move my a's over to one side. I think I'll move the 2a over here so that I have a positive a. And then I'll move my 2 over to the left and I'll get a is 4. So my solution for this is 4. It's not a restricted value, so we are good. All right, just a couple more. 5 over 3x minus 3 minus 2 over x minus 2 equals 7 over x squared minus 3x plus 2. All right, so this one is a little more complicated. You can see we have some binomials on the bottom. We have a trinomial here. In order for us to be able to find our restricted values and our least common denominator, we probably need to break these down to their smallest factors that we can. So I see 2 of these that will factor. So I'm going to go ahead and factor these denominators. This one I can take a 3 out. So I'll have 3 times x minus 1. This trinomial can be factored to x minus 2 and x minus 1. Okay, so now I can see all my different factors for my denominators. I can also see what values will make these denominators 0 and therefore be restricted values. So I know that, x minus 1 would be 0 when x is 1. So 1 is going to be a restricted value because 1 would make this 0, it would make this denominator 0. Another value that would make the denominator 0 is 2. Right here, a 2 would make this denominator 0. It would also make this 0. So I have restricted values. X cannot be 1 or 2. All right, for this problem. Now, my least common denominator is going to be made up of all of the different factors that we see in these denominators. So I'm going to need a 3, I'm going to need an x minus 1, and I'm going to need an x minus 2. So all 3 of those things in my least common denominator. So I'm going to have to squeeze all that in up here because that's what I'm going to have to multiply each of these rational expressions by. So this one, I'm going to multiply it by 3 times x minus 1 times x minus 2. And the same thing here. Let me see if I can squeeze it in. 3x minus 1, x minus 2 times this one. And here, 3 times x minus 1 times x minus 2. Should have probably left a little more room. All right, let's see what's going to happen here. the 3 and the x minus 1 will cancel. The x minus 2's will cancel. And the x minus 2 and x minus 1 will cancel. Now I need to be careful right here. That's making me a little bit nervous. I'm worried I'm going to leave this minus off. So I'm going to go ahead and put that right there on the 2, so that when I multiply this together, I won't forget about it. All right, so here I have 5 times x minus 2, and that's going to give me 5x minus 10. Here I have negative 2 times 3, which is negative 6 times x minus 1. So if it makes you feel better, we can do that in steps. We can bring that down, negative 6 times x minus 1, and we'll do that in a minute. All I did on that step was multiply the 3 and the negative 2 together, and I brought that down times the x minus 1. And over here, I have 7 times 3 is 21. All right, so now I'm going to distribute that out, and I'm going to get negative 6x plus 6. And then I can combine my like terms. 5x minus 6x is negative 1x. Negative 10 plus 6 is negative 4 equals 21. I would add 4 to both sides, and I would get 25, and then divide by negative 1, and I end up with negative 25. Now, we had 2 restrictive values, but we did not get either of those for our answer. All right, let's see. Let's do another here. P over P minus 4 minus 5 equals 4 over P minus 4. Okay, so restrictive values for P. Anything that would make this denominator 0 would be a restricted value. So if we solve that, we see that 4 would be a restrictive value. You can see pretty easily if you plugged 4 in right here, it would make the denominator 0. Or right here, it would make the denominator 0, which would make these undefined. And that's why this is a restricted value. So P cannot be 4. All right, my least common denominator, well, I already have a common denominator, P minus 4. So that's what I'm going to multiply everything by, P minus 4. Don't forget that's a negative 5. I'm going to go ahead and do it like that. It's a binomial, so I like to keep it together. All right, so we got that's going to cancel, and this is going to cancel. So here I just have a P left. I went ahead and grouped that negative in there so I wouldn't forget about it. Negative 5 times P is negative 5P. Negative 5 times negative 4 is positive 20. And here I just get 4. Now, 1P minus 5P is negative 4P. Then I can subtract 20, which will give me negative 16. Divide by negative 4, and I get positive 4. But wait, P cannot be 4. And since 4 is the only solution I got, and P cannot be 4, then this rational equation has no solution. Okay, so you can do the empty set like that. You can do this for no solution, which means there's no value of P that would make this equation true that doesn't make it also undefined. So see, P, as if we put 4 back in, it would make these two undefined, so we can't do that. All right, one more problem and we will be done. All right, we have 6 over x squared minus 7x plus 12 plus 2x over x minus 3 equals 3x over x minus 4. Okay, so this one is similar to the one we had up here in that before we can really determine all of our restrictive values or even our common denominator, we need to break our denominators down into factored form whenever possible. So I see that this denominator here can be factored right here, so I'm going to go ahead and factor that to x minus 3 and x minus 4. And these are broken down as much as they can be, and now I can see what my restricted values are. Alright, so I know that 3 would be a restricted value because that would make this denominator 0, it would make this 0. I also see that 4 is a restricted value because it would make this denominator 0 and this one 0. So I have two restricted values, 3 and 4. My common denominator is going to need an x minus 3 and an x minus 4 in it. So I'm going to come through and I'm going to multiply each rational expression by that common denominator. And what that should do is allow me to cancel these denominators out. So these are both going to be gone along with that. Here the x minus 3s are going to be gone, and here the x minus 4s are going to be gone. So let's see what we have left. Here we just have a 6. Here we have 2x times x minus 4. Now I'll just bring that down like that, and then we'll distribute it in just a minute. And then equals, and on this side we have 3x times x minus 3. Alright, now I'll distribute all this out. That would be 2x squared minus 8x. On this side, it would be 3x squared minus 9x. Okay, so I see we have x squareds in here, which leads me to believe we're going to have a quadratic equation unless they all cancel out. And so I'm going to go ahead and move everything over to one side. I like my x squared term to be positive, so I think I'm going to move everything to the right, because when I subtract 2x squared, that will leave me with a positive x squared over here. So I'm going to go ahead and also add 8x over here and subtract 6. Alright, so I'm going to be left with 0 on this side. And over here I'm going to have x squared minus x minus 6. And so in order to solve that, we'll need to factor or do quadratic formula, whatever you prefer. I prefer factoring. That easily factors to x minus 3x plus 2. And then using the zero product property, I would know that one of these two factors has to equal 0. So either x is going to be 3 or x is going to be negative 2. So we got two solutions for x. However, we had two restricted values, and 3 was a restricted value. So we're going to have to throw this solution out, and we will only have one solution, which will be negative 2.